Welcome to True Projects. In this video, we are going to explain about the project, which is Security and Privacy of Electronic Health Records Sharing using Hyperledger Fabric. Coming to the introduction, the management and the security of electronic health records are critical concerns in healthcare industry due to the sensitivity of patient data, privacy obligations, challenges in the data management and access control, data accuracy, cybersecurity threats, and regulatory compliance. Addressing these issues, it is essential for maintaining trust, privacy, and integrity of patients' information. The traditional healthcare systems, electronic health records are often stored in centralized databases, making them vulnerable to data breaches and unauthorized access. Patients have limited control over their data, and healthcare providers have broad access rights. The project utilizes blockchain for data security and immutability, and it implements Hyperledger Fabric for permission control and employs strong data encryption techniques to protect patient information. This approach empowers patients with full control over their data access, enhancing privacy and security. Blockchain, a distributed ledger technology, records transactions on a computer network renowned for security, transparency, and immutability. Immutability ensures data integrity, while decentralization via a node network heightens security and transparency by implementing central authority. Coming to the objective, the goal of the project is to implement blockchain technology with immutable transactions, making it extremely challenging for unauthorized parties to alter or modify patient health records, thereby enhancing data security. The goal is to utilize Hyperledger Fabric permission-based API to enable patients to grant or revoke data access to specific users, including doctors, insurance companies, and government agencies, with the overarching objective of giving patients full control over their health data. The objective is to secure patient data in the database through the application of blockchain encryption techniques and hashcode verification. This approach adds an additional layer of data protection, maintains data integrity, and acts as a deterrent against unauthorized data alterations. A hashcode, a fixed-length alphanumeric string generated by a mathematical algorithm from the data, serves as a digital signature for data integrity and security. Integration of hashcodes in the project enhances data security, detects tampering, and ensures data integrity, aligning with the project's core objectives. To implement this project, we need hardware and software requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and ROM of 25 GB and above. In software requirements, we need Node.js, Python of 3.7.0, and Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first module is Sign Up. This Sign Up module allows users such as patients and healthcare agents to register on the platform. During the registration process, users provide their personal information and create their accounts. Patients can create their medical profiles, and healthcare agents can specify their roles such as doctor, insurance company representative, or government agency user. Coming to the agency login, the agency login module is designed for healthcare agents, and these agents can log into the system using their credentials. This login provides them with the access to specific functionalities, primarily related to viewing patient data to support healthcare services, insurance decisions, or government health analysis. Coming to the next module, which is Access Patient Data, the Access Patient Shared Data module is an essential part of the project's functionality. Healthcare agents, once logged in, can use this module to request access to patient data. Patients have previously granted permissions to the specific agents to access their health records. This module allows authorized healthcare agents to retrieve and view relevant patient data for their respective purposes such as diagnosis, insurance assessment, or government health monitoring. Coming to the next module, which is Insurance Company Login. Insurance Company Login module is a specialized login interface for insurance company representatives. These users can log in with their credentials and access functionalities related to insurance policy decisions and assessments based on the patient's health data. This login provides them with the access to patient data they are permitted to view. The next module is Patient Login. This module is designed for patients who have registered on the platform. Patients can log into their accounts using their credentials. Upon logging in, they can access their own medical profiles, view their health records, and monitor who has requested and access their data. The login module empowers patients with the control and visibility over their data. Coming to the blockchain integration, patient health records are stored securely on the blockchain. The blockchain's immutability ensures that the data remains tamper-proof and secure. Patient data is securely encrypted using blockchain encryption techniques, enhancing the confidentiality and security of the records. Each transaction on the blockchain is associated with a hash code. These hash codes are used to verify the integrity of patient records and to detect any tampering with the data. Hyperledger Fabric, a permission blockchain platform, is used to manage access permissions. It ensures that only authorized users based on the patient permissions can access the data. This is essential for maintaining data security and privacy. For execution of the project, first we need to open the code folder which contains source code files. So here we have the code folder. This is the secure EHR folder. Inside this folder there are Python code files that are intended to be dynamically loaded into project code during runtime. And here we have secure EHR app folder. This folder comprises of a static folder, templates folder and Python code files. Coming to static folder, it contains files related to CSS, JavaScript and Bootstrap files. These files contribute to the visual and interactive aspect of the application. Coming to the templates folder, within this folder we will find all HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. Coming to the Python code files that will be executed during the runtime of the application, supporting its functionality. And here we have manage.py file. It is a command line utility that comes with the Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, and applying migrations and more. And here we have run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Now we need to double click on it to start the Django application. Django framework will host the application locally at the default address, which is localhost and the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. So here we'll paste the link. At the end we need to type index.html and click on enter. We can see the web page of the project is displayed in the browser, and this web page is built by using the Django framework. Here we can see various links which are patient login link, agency login link, new patient sign up here link and new agency sign up here link. So first we will click on new agency sign up here link. Here we need to enter all the user details to create an account, and here we can see users with various types. So first we will create account of the doctor. So here we will give the username of the doctor, password, contact number, email ID, address, and in agency type we need to select doctor and then click on create. Here we can see that doctor sign up process is completed. Similarly, we can add other types of users also. So now we will create account of insurance representative. So here we will give the username and then the password, contact number, email ID, address, and in agency type we need to select as insurance and then click on create. Here we can see that insurance representative sign up process is completed. Now we will create account of government agency representative. So here we will give the username, password, contact number, email ID, address, and in agency type we need to select government agency. Now we need to click on create. We can see that sign up process is completed. Now we need to click on new patient sign up here link. So here patient can create his profile, so we will create patient's profile. So here we will give the name, age of the patient, problem of the patient, And in agency type, I'm selecting doctor, which means we are giving permission only to the doctor. And here, in the gender, we are selecting female. And in contact number, here we will give the contact number. Here we will give the address. And then click on create. We can see that profile creation process is completed and his patient ID is 1. So now we will create other patient's profile. So here we will give the patient name, age of the patient, problem description, agency type will select multiple agencies, which means we are giving access to multiple agencies. In gender, we are selecting female, and here we are supposed to give the contact number, and here we are supposed to give the address, and then click on create. We can see that profile creation process is completed and the patient ID is 2. So here in this console we can see blockchain hashcode generated for each patient profile, and here we can see that in the selected text we can see current hashcode of block. Old block will be matched with previous hashcode of next block. This matched hashcode will be verified for transaction as secure and successful. Now we will get back to the application and log in as doctor. So for that we need to click on agency login. Here we need to provide username of the doctor. So the doctor username is Ravi, and here we are supposed to provide the password and then click on login. Here we can see that the doctor has logged in successfully. Now we need to click on access patient shared data to view access patient data. Here we can see all patient records as patients are given permission to doctor. Now we will log out and log in as insurance company. For that we need to again click on agency login. Here we need to provide username and the password of the agency, which means insurance representative. And here we are supposed to give the password and then click on login. So here we can see that insurance representative has logged in successfully, and now we will click on access patient shared data. Here we can see only one patient's records, which means only this patient has given the permission. Now we will log out and log in as patient. For that we need to click on patient login. Here we will provide patient ID. So the patient ID is 1. Now we will click on login. So here patient can view his profile and the hashcode generated by the blockchain link to link with his records. Now we will log out. By this, patients can keep their records safely and control their data. Conclusion of the project. The project successfully leveraged blockchain technology and Hyperledger Fabric to fortify the security of electronic health records, ensuring that patient data remains protected against unauthorized access and tampering. By granting patients control over their medical data and permission access, the project has empowered individuals to actively manage who can view their records, safeguarding their privacy and rights. Through the use of hashcodes and blockchain immutability, the project has established a robust system for verifying data integrity, detecting tampering, and maintaining the trustworthiness of EHR. The project aligns with the healthcare data regulations and offers transparent and permission-based access to authorized entities, promoting regulatory adherence and data transparency.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.